Hello and welcome back to Introduction to Business Analytics. My name is Hari Rajgopalan and I'll be your instructor for this session. So we are working through our way in predictive analytics and we're really talking about regression, and we talked about multiple regression. Let's talk a little bit about intercept and what do we do when our intercept is not statistically significant, and what does that mean and what are the implications for that. So we go back to the price of a house, and we have the square feet, the garages, the bedrooms, the different houses, and we end up with a final model where number of bedrooms are removed. We get an intercept, the slope, and you find that the intercept, the p-value for the intercept is 2.39%. Now, so long as your alpha is 5%, you're okay. But what if your alpha was 1%? Then the intercept is not significant. Now, your square feet and garage are significant, but intercept is not significant. So in this particular case, we would have to relook at the intercept. And let's talk about the intercept and constant here. So the constant term in regression analysis is the value at which the regression line crosses the y-axis. Mathematically, it is the value of y when x is 0, and that's kind of easy. But to explain it in reality is not that easy, and it can get very complicated. So it's frequently, especially in multiple regression, it is frequently impossible to set all variables to 0 because this combination can be impossible or an irrational arrangement. You could also get a negative intercept. Let's take the example of price is equal to minus 100 plus 25 multiplied by the dollars you spend in advertisement. Well, what does minus 100 mean? Does it mean that when you don't have any advertisement that you're going to pay people to buy the product? So sometimes the meaning of the intercept can be really absurd. And negative y-intercepts for this regression model has no real meaning. So when that happens, don't try to give it 1. And what happens in multiple regression? How possible is it for all of them to have 0 simultaneously? Remember, you have more than one x-axis then, and you can it might be impossible for all these different variables to be 0 at the same time. So y-intercept also might be outside the observed data, a point outside the range of observed values. You cannot make predictions because the relationship might change. You don't know it because you don't have the data. And having the intercept or constant, remember when we did the assumptions for the regression model, constant is used to absorb the bias for the regression models. You can assume all the predictors can be reasonably equal to 0 and you can collect data in that area, and your intercept might still be garbage. A portion of that estimation process for the y-intercept is based on the exclusion of relevant variables from the relevant model. So when you leave the relevant variables out, this can produce bias in the model. So constant ensures the residuals do not have bias, but that might make the constant meaningless. So when we talk about don't make predictions outside the range, let's say we have only data right up to x being about 5, and then below 5, it might still be a straight line, or it might go something like this in an angle. So we really don't know what happens there. So what do? We include the constant in a regression model, and this forces the residuals to have a crucial 0 mean. If you don't include it, you will be forced to set the constant equal to 0. It forces the regression line to go through the origin, which is where both x and y are 0, meaning a model that does not include the constant requires all of the independent and dependent variables to equal 0 simultaneously. Now that's even harder, right, to get a real situation. So you can ignore the constant as 0 option for regression analysis, And if the p-value for intercept is less than alpha, then the intercept is significant. Otherwise, you just mentioned that it's not statistically significant. So here is the method where you force the constant to be 0. Let's go to Excel and I'll show you how to do it when the constant is 0 and what the results are. And you can choose not to do this and just keep the intercept as it is. Okay, so we know the final model here contains only square foot and garage, and we have a problem with the p-value for the intercept. So we're going to look at an example where we have intercept as 0. We are going to select the price. The X values are only square foot and garage. We are not going to select bedrooms. Labels, confidence interval, constant is 0. All of that is selected. And then we have our output range right here. So click OK, and we get the summary output here. Let's do a quick formatting so that these are all percentage values, and then these here will all be numbers. And you will immediately notice that compared to the final results where we are explaining more, this one actually ends up explaining less. Adjusted R squared is 96.34, whereas here is 99.42. And your garage now is no longer significant. And so if you actually use the method, you'd have to remove garage, because what we're doing is we're forcing this intercept to essentially go through, let me get a pen here. We're forcing the intercept to actually go through this line. And so since we are forcing it, instead of it being here, we're forcing it to go right to the center. It skews the result, and we actually get a worse result. So while you should know how to do this, put the intercept as 0, we can see there are some real problems by putting the intercept as 0. And so normally, unless the intercept is significant, I mean, like there's a huge p-value, for something like this, 2.39%, we can keep it, but we can tell the thing that this was non-significant at alpha is equal to 1%. So as we saw from the Excel file, when we have this intercept problem, you end up with the intercept having no p-values. You force the data to go through the center, which skews the data, and it might actually affect the other variables which are significant. So it's really not the best approach, but it is an approach which is available, especially if the intercept is highly not significant. The p-value is like 30, 40, 50%. We really have a garbage intercept, and so it is important to acknowledge that as we are doing this regression problem.